All right, today we're going to test a claim about a population mean again when the population standard deviation is known. That means you know baby sigma. We've actually spent the last 2 days doing the first part, testing claims about population means, but we haven't known what the standard deviation of the population was. So this is a tad bit different, very little difference in the two, and I think you'll find out this is more practice doing pretty much the same thing, but still a great practice. So here we go. All requirements must be the same. The data must come from a simple random sample, as always, and it must be normally distributed, or the sample size must be greater than 30. All right. When population standard deviation is known, we use a test that involves a standard normal distribution. Sorry about that, which means we're going back to z's instead of t's. All right. So when it's known, we're going to do z-scores instead of t-scores, or z-crit instead of t-crit. In reality, it's very rare that this happens because you very rarely know what the population standard deviation is. But occasionally, you may know it, or it may come into play, so you got to know how to deal with it. Procedure is essentially the same as a z-test, except there's one big exception, and here it is. The exception is it's a z-test stat instead of a t-test stat. If you look at the numerator of a fraction, it's exactly the same. If you look at the denominator of the fraction that we did last week, or yesterday, or the day before, whenever we did that, it's the same, except it has a baby sigma here. It has population standard deviation instead of a little s for sample standard deviation. That's the only difference in the formulas. 2 days ago, we actually worked out the test statistics, and then the next day I gave you the technology to do it. They would do it for you. And so then we're right back to kind of where we were with the test stat. The p-value we can do in the calculator, the same way we did normal distribution, where we did normal CDF. That's how we did that. The critical values can be found doing inverse norm. All right, one example here, and then we'll be done. It says, if we repeat the cell phone radiation example, this is from a video a little while back, the assumption was this, that the standard deviation was 0.480. And in that example, this was from a couple of videos ago, we knew that that was the sample mean, that was the population mean, that was the sample size. So all I'm doing differently here is I'm substituting the population standard deviation where I used to put the sample standard deviation. That is the only difference, and I got that for a test stat. And so I did is I plugged that into normal CDF to get my p-value. The p-value was this, and the test stat wasn't past my critical values. So, and since p is bigger than 0.05 or 0.1, whichever one you would be using, we would fail to reject the null. And that's it.